Friday answers. The diagram shows a scale drawing of a cooling tower. What is the actual height of the tower? And we've got the scale 1 to 200. So if I measure 1 centimetre, the real thing is 200 centimetres high. If I measure it as 2 centimetres, the real thing is 400 centimetres high. If I measure it at 3 centimetres, it's 3 times 200. If I measure it at 4 centimetres, it's 4 times 200. But I've measured it at 4.5 centimetres. So it's 4.5 times 200. Now remember that 200 is 2 times 100. And when we're multiplying, we don't have to worry about the decimal point. So I'm going to say 45 times 2 times 100. What's 45 times 2? Well, 45 times 2 is 90. Times 100 means put 2 more zeros on, and then deal with this decimal point. In the question, there was 1 digit behind a decimal point, so in the answer must be 1 digit behind the decimal point. So the answer is 900 centimetres. 900 centimetres. Now if we go back to the question, it's asked for us to give the answer in metres. So I'm in centimetres. Small thing, high voice, high number. So I've gone from high number. And I want to go to metres. Big thing, low voice, low number. So how do I get from a high to a low number? I divide. What am I dividing by? Well, 100 centimetres is a metre, so I'm dividing by 100. I want to divide 900 by 100. And the easiest way to divide by 10 or 100 is to get rid of the zeros. So I've got 9 metres, and that's my answer. Question 2. Write in the missing numbers. 1.85 metres is 30 centimetres more than 1.55 metres. Some metres is 30 centimetres more than 64 centimetres. Well, first of all, I'm going to add 30 centimetres to 64. And that equals 94. Now the box I've got to fill in is actually in metres, so I'm starting with 94 centimetres, high voice, high number. And I want to go to metres, low voice, low number. How do I get from high to low? You divide. What am I dividing by? There are 100 centimetres in a metre, so I'm dividing by 100. So if I divide by 100, my decimal point starts here, and I'm going to move it 2 places to the left. 1, 2. So I end up with 0.94. And that's what we're going to write in our box over here. Next one, some centimetres is 30 centimetres more than 1.09 metres. Well, I'm starting with 1.09 metres, and before I do anything else, I'm going to change it into centimetres. Are we starting with the big thing or the small? We're starting with the big thing with the low voice, so it's a low number. And we want to get to the little thing with the high voice and the high number. How do we get from low to high? We times. What are we timesing by? We're timesing by 100. So 1.09, we're going to move the decimal point 2 places to the right. 1, 2, and that will give us 109. Now I need to add my 30 centimetres on. So 109 plus 30 would give me 139. And we can write that over here. Last one, 1.65 metres is 30 centimetres more than some other centimetres. So I'm starting with 1.65 metres. Is that the big thing with the low voice or the little thing with the high voice? Big thing, low voice. And I want to take it to centimetres. Little thing, high voice. How do I get from low to high? To get from a low number to a high number, you times. I'm timesing by 100 because there are 100 centimetres in a metre. Right, so we started with 1.65. If I move the decimal point this way, I'd end up with 0 point something that's less than 1. I'm trying to make it higher, not lower. So if I move it this way, then it'll start getting higher. And because we're timesing by 100, one move for each 0. So 1, 2 would give me 165. Then we've got to take our 30 centimetres off because this is less, 30 centimetres less than that. So let's take 30 off because we're working the other way around, we're doing the opposite. And of course it's 135. Just do that in my head and we can write that over here. Okay, circle the distance that is closest to 1 mile, and 1 mile we're told is 1.66 metres. So what I'm going to do, 1.66 kilometres, what I'm going to do is turn everything into kilometres and then we'll see which is closest to 1.66. So starting with this, so we've got 3, 4, 6, 0, 0 metres, and we want to go to kilometres. Kilometres are big, so they have a low voice. Metres, in compared to kilometres, are small, so they have a high voice. How do you get a number from being high to low? Do you times or divide? We want to make it less, so we're going to divide. And we're going to divide by 1,000. Remember, kilo means 1,000, and there are 1,000 metres in a kilometre. So let's take our number here and divide it by 1,000. The decimal point is here. I'm going to move it this way one time for each 0 on 1,000. 1, 2, 3. That would give me 34.6. Let's try 1.7 metres. So we've got 1.7 metres and we want to go to kilometres, which is the small one, which is the big one. Well, here we've got the small one with the high voice. Here we've got the big one with the low voice. How do we get from high to low? We divide. And we're going to divide by 1,000. Right, so the decimal point started here, and we're going to move it 3 places this way to the left, left for lower. 1, 2, 3. And I end up with 0.0017 kilometres. So we'll write that in here. So that's nowhere near 1.66, is it? Let's try the next one. I've got 16,000 millimetres. Now they're really small, and I want to go to kilometres. I'm going to write the kilometres down here. because I don't want to make any mistakes. Right, millimetres there's 10 of those in a centimetre. So if I turned it to centimetres, here's the high voice, here's a lower voice. I would divide that by 10. Then if I did the same, turn my centimetres into metres, there's my high voice, there's my low voice. I'm going to divide, this time there's 100, so I can divide by 100. Now I'm in metres, so I'm at 160 metres. That's a bit of an easier number to turn into kilometres. If I want to go to kilometres, that would make this my high voice and this my low. So to get from a high to a low, divide. And we'll be dividing by 1,000 because there's 1,000 metres in a kilometre. So I'm going to put a 0 in front because I might need it. My decimal point is here, left for lower. 1, 2, 3. So it's 0.16. We don't need the end 0. Kilometres, let's write that in here. 1700, and that's centimetres. Right, first of all I'm going to change it to metres, so take 2 off. So we've got 1700 metres, and I want to go to kilometres. Which is the big one? This one. This one's the big one with the low voice. This one's a little one with the high voice. To get from high to low, divide. We're talking about kilometres, so we're dividing by 1,000. The moment my decimal point is here, left for lower, and we're going to go 3 spaces. 1, 2, 3, which gives me 1.7. So let's write that in. Last one, 166 metres. So just clear this. 166 metres. I want to go to kilometres. High voice, low voice, because it's the bigger thing. Get from high to low, we're going to divide. We're talking about kilometres, so we're dividing by 1,000. Decimal point at the moment is here. Left for lower. 1, 2, 3. So my answer will be 0.166. So the closest one is going to be this one. Next question. In order to classify for second class post, a parcel must have a volume of less than 1,500 centimetres cubed. But before we start, let's remember how we work out volume. And it equals length times width times height. Which of these parcels may be sent as second class post? So we've got to work out the volume of each of them and check that it is less than 1,500 centimetres cubed. So parcel A equals 9 times 10 times 14. Well, I'm going to do 9 times 14 and then times the answer by 10. So 14 times 9. 9 fours are 36. 9 ones are 9, add 3 is 12. And then I've got to times it by 10, remember. So let's just put a 0 on here so that looks correct. This one is 1260 centimetre cubed. Is that less than 1,500? It is, so that one can go. But let's just check the other one as well. Right, so this one we've got 18 times 4 times 21. So I'm going to do 4 times 21 first, which is 84. And then I'm going to times that by 18. Long multiplication, 0 down, 84. 8 fours are 32. 8 eights are 64, add the 3 is 67. And then we're going to add those two together. That's 2, 11, 14, 15. 1512 centimetres squared. So that is more than 1500, isn't it? Only just, but that won't go. So this is the answer A. Last question. Paul is building a path across his garden. The path will be 14 metres long. How many paving stones will he need? Right, so he wants a path that is 14 metres. How many paving stones will he need? And we're shown that 3 paving stones are 210 centimetres. So the first thing I want to know is, what is 1 paving stone? So 3 paving stones, so that's 210. I want to know what 1 paving stone is. How have I got from 3 to 1? I've gone from higher to lower, so I must have divided. And when I get 1, that means I've divided by 3. So 1 paving stone is 210 divided by 3. And if we just ignore this for a second, we can just say, what's 21 divided by 3? Well, that's 7. But it wasn't 21, it was 210, so it's 70. So 1 paving stone is 70 centimetres. How many will I need to make 14 metres? Well, metres and centimetres can't work together in the same calculation, so I'm going to have to change the metres into centimetres. So I've got 14 metres and I want to go to centimetres. Which is the big, which is the small? Big with a low voice, small with a high voice. How do I get from low to high? I'm going to times. We're talking about centimetres, so it's 100. So 14 times 100, well, that's 14 and times 100. 1400 centimetres. And I want to know how many 70 centimetre paving stones will I need to make it that long. So it has to be 1400 centimetres altogether. So if I just draw my little path, and here's all the little paving stones. Now altogether it's 1400. And each one is 70. So can you see I'm splitting it, I'm dividing it into 70s. So we need to divide. So I'll just clear this. So we want 1400 divided by 70. 1400 divided by 70. Now that's the same as saying 140 divided by 7. Just check that. Say I had 10 divided by 2, that gives me 5. If I have 100 divided by 20, that gives me 5. So as long as I divide both sides by 10 and take one of the zeros off, it works. I can't just take one off here and not off there. It has to be both sides, a bit like a fraction. In fact, if I wrote it out as a fraction, you can see why that would work. Because remember, a fraction is an unfinished division sum. So I'd end up with 140 over 7. So let's write it out as a normal division sum. How many 7s in 1 won't go? How many 7s in 14? 2. How many 7s in nothing? None. And the answer is 20. I will need 20 paving stones. Underline the answer.